Map is a data collection type, in which data is stored in a form of pairs, which contains a unique key and value mapped to that key. And because of the uniqueness of each stored key, there is no duplicate pair stored. With maps, you have to define a key, and you have to define a value, just like with sets. When we added a value to a set, we had to pass in the value of that set. But instead, with map, we actually have to pass in the key and the value. Notice that instead of add, we're using set, so we're setting the value and we're setting the value of the key, and we're setting the value of that key as well. It's really important to know, because when we want to reference this map as well, we want to grab the key. We need to know what that key is to be able to identify. Maps are a storage location, just like sets are, but we're storing different types of values in this key-value pair. We can have strings as part of the key. We can have numbers as part of the key. We can even have functions as part of the key. And we can have objects as part of the key as well. It just depends on what you want to use and how you want the map to function. The map uses a key-value pair, and it keeps the original insertion order. That's important to know. Any value, like objects or primitive values, can actually be used as either the key or the value. You can do something similar with keys and values with arrays. But the problem with the arrays is if you try to iterate in order, there's no guarantee that it will actually go in the order that you've inserted it, but with maps there is a guarantee. Let's talk about the properties and methods that come with maps. We can get the size of the map, but we don't have access to a lot of other properties there. But for as far as methods go, we have clear so we can clear out the map completely. We have delete so it can delete specific items of the map as well. We have entry so we can get into the entries of the map. We have for each to be able to iterate it through them. We have get so we can actually get the value. We also have set so we can set the value as well. We can check to see if a map has a certain value. We can also access the keys if we want to just get all the keys for all the entries. We can go in and just access the keys, and we can access the values. Let's talk about creating a map and adding and removing values from that map as well. Map has only one way to create, by using its built-in constructor and new syntax. Map supports adding new element by providing map prototype.set, which takes two parameters, key, value. But if you pass an existing key, it will overwrite the value mapped to that key with the new value. If you want to access an element value, you can do that by using the get method. Accessing an element value is done by map prototype.get, so we need to know the key to be able to retrieve the value of an element. Map has few nice built-in methods to support different removing purposes, such as delete for removing a target element with a specified key from a map, and clear to remove all elements from a map object. Delete returns a Boolean variable, indicate if target element with specific key did exist in the map and was removed successfully, or if that target element does not exist at all in map. Checking if a key is already in map is supported by has. Map does keep its size updated automatically, and we can always get the size easily. Map is built-in iterable. There are the two different ways to be able to iterate. We have the for each and we have the for of as well. If you're familiar with objects, you're familiar with the arrays. Why are we not just using objects? There are a couple big differences. The first one is being able to iterate so much faster through a map than you can through an object. There is a difference in the key value, the key and the object. The keys must be simple data types. That means you can only have integers. You could only have strings, or you can only have symbols and really nothing more than that. For maps, you can have any data type. You can have those primitives. You can have objects as well as a key. You can have the object. You could have arrays. You can have functions. You could pass in a spread operator for the array. Another one is element order. So keep in mind that with objects and arrays, you essentially can't guarantee the insertion order. It could be jumping all over the place, but with maps you guarantee the insertion order. Another one is inheritance. A map is inherited from an object. That means that as a map, I can actually go in and get the methods and difference properties of an object. But an object is not a child of a map, so you can't actually inherit some of those methods inside of an object. And so you don't get some of the methods that make it a little bit easier to work with, like just being able to use has or being able to use set and get as far as setting the data of the map. Let's look at some differences between a map and a weak map. In this case, you cannot have a key value as a primitive value, so you have to have it as an object. Now the objects similar to sets are actually held weakly, and so if it's there, it's there. If it's not there, it's not there. And they're not iterable, just like weak sets. You cannot operate through a weak map, and they're also garbage collecting. And so if it's not necessary for that to be stored inside of data, it will automatically free it up. So weak maps, they're also not enumerable. Enumerable means that they cannot be fully counted. So even though I created a map, if it's not being referenced, I can't count on that in that certain number. In maps, you can use keys and values and clear and entry and for each and getting set and has. But for weak maps, you can only use delete, get and set and has, and that's really it. You're basically down to those different methods to be able to get to set to delete and to check to see if the value is there.